Welcome back to Maths with Adi, where you have access to mathematics courses for free. This is Algebra Fundamentals, and today we are going to talk about difference of two squares and sum of two squares. Okay, so we can talk about this first. If it doesn't make sense, if these phrases, what is difference of two squares and what is sum of two squares? If it doesn't make sense, this will make sense right now. So we can talk about difference of two squares first, because that is used more than this. Okay? But both are actually fundamental, basic things. But I've seen this being used more than this one. Okay, but you cannot compare, as both of them are important, and you cannot learn one and not learn the other one. Okay, because both are important. If you want to master algebra, you have to actually build up your basics. So let's talk about the first one, which is difference of two squares. So this is actually implying this thing, a squared minus b squared. How is this implying this one? We have two squares here, as you can see, a squared minus b squared. Okay, so you have the square of the first number and the second number, and this shows the difference, meaning subtraction. Okay, so basically this is saying this thing in words. So this is difference of two squares, meaning a squared minus b squared. So what this thing is equal to? This thing is equal to, in factorized form, this is equal to a plus b times a minus b. This is again a basic formula. Memorize this, note it down. Okay. Also go over the proof, which I'm going to show you right now. Okay. And we are doing special products right now. Okay. So these are special products. I've shown you a couple of special products. I'll talk about. I'm go over all the special products in just one video after finishing all of them. Okay, after finishing all of these. So as we are talking about special products, we're gonna focus on the product side. Okay, meaning we're gonna find the product of these two, and we should be getting this thing. Okay, you could also prove this from this side. Okay, using geometry. Okay, and there's another way as well. Okay, an algebraic way, but this is actually more seen and more common. Okay. So let's actually do this. Okay, simplify this. So you're gonna get a times a minus b. You have distributed this into this whole. You should be familiar with these process till now, because it's been quite a long time since we have been doing all of these. So this will be a squared minus ab plus ab minus b squared. Okay. Now these two will cancel out. Okay, because you have minus here plus here, as you might know already. So you will be left with now a squared minus b squared. Now this is stating that this thing is equal to this. The proof, we have proven it, that this thing is equal to this. Okay, note this down if you want to. Okay, by pausing the video, and I'm gonna wipe this. So that was the first formula, first basic formula. Okay, so you have to memorize this as well. Second one is sum of two squares. Okay, so you have a squared plus b squared. Okay, so this is what you have. Okay, so a squared plus b squared. Sum of two squares. Okay, as you can see, and you also might have guessed it. Okay, might have also got your brain around it. Okay, it's pretty simple. So this thing is equal to a plus b to the whole square minus 2ab. You can also write it another way. Okay, there is also another formula for this. Okay, another way also, and that is a minus b to the whole square plus 2ab. Both are correct. Both the expressions, both the equations are correct. Okay, you can write in either ways you like and need it. Okay, so to prove this, I'm gonna use this side. So there are two ways to prove this. First, let's use the method of solving this to get this. Then we're going to talk about the second method. Okay, so let's simplify onto this side. So you're going to have, so what you have is a plus b to the whole squared minus 2ab. If you simplify this, you're going to get this thing is same as the formula that we have talked about. Okay, if you don't know the formula, please go over my previous videos. They are in the same playlist as this. You can also watch it, and the links to those videos are also in the description box. So do check them out. So this is equal to a squared plus 2ab plus b squared, then minus 2ab. Okay, and these two will cancel out. As you can see, here we have plus 2ab and this is minus 2ab. Now this will be a squared plus b squared, meaning indeed these two are equal. Okay, let's talk about another equation. Okay, so a minus b to the whole square plus 2ab. If we solve that, we should be getting this thing again. So this is a squared minus 2ab plus b squared. Again, I have made a video onto the formula of this. So all I'm doing is expanding this one. I have also expanded this over here. So plus 2ab, these two will cancel out and we will be left with a squared plus b squared. Meaning again, this thing is equal to that one, and this is true. Okay, and the way to memorize both of these formulas is that when you have plus, when you write plus here, do write minus. When you write minus, do write plus onto the other side. Okay, so that was the proof and the formulas. So note it down if you want to note this down by pausing the video, but I am wiping this up. Okay, so I messed it a little. It's still fine. It's visible. It's visible anyway. So, okay. So that was the formula, and this was the first method. Okay, first method. There's also another method to deal with this. Okay, and that is, and I'm showing the second method, and I'm showing you the second method now. And the second method is you derive it. So it's not working quite well. So you derive it from, you derive a squared plus b squared from the formula of a plus b to the whole squared. And you know that this quantity, this thing, is equal to a squared. Okay, so let's get a little bit more space by wiping this up. So you want to find out what a squared plus b squared is equal to using another method. And I told you that this can be proven or found out from this equation, which is a squared plus 2ab plus b squared. Okay, you can figure this out from this equation as well. So how do you figure out? How do you figure out that? As you can see, that a squared plus b squared, is inside of this equation. So why not? Try to solve for this a squared plus b squared. Then we have to take this onto this other side. So be a plus b to the whole square. If you take this onto the other side, it will be minus 2ab, and onto this side, it will be a squared plus b squared. This means that a squared plus b squared is equal to this thing. Okay, so if we rearrange it, a squared plus b squared is equal to, it will be a plus b to the whole square minus 2ab. So this is the formula that we had previously, the same formula that we wrote just a while ago. So you can see that this also is proven from this equation, and you might be wondering that this also can be proven from another equation, and that is a minus b to the whole squared. Okay, so when we used a plus b to the whole squared, we got plus here and minus there. Let's see what do we get if we use a minus b to the whole squared. Okay, so yeah. Let's do it here. A minus b to the whole squared is equal to a squared minus 2ab plus b squared. Now, let's again figure out for a squared plus b squared. Let's see what do we get. So you're going to get a minus b to the whole squared. We have to take this onto this side. So plus 2ab. All that we will be left with onto the other side is a squared plus b squared. Meaning a squared plus b squared is equal to a minus b to the whole square plus 2ab. This is what it is equal to. So when we used a plus b to the whole squared for solving for a squared plus b squared, we got this thing, plus here and minus there. Okay. When we used the other one, or a minus b to the whole squared, we got minus here and plus onto another place. So this is how we get both of these formulas, and hope this is clear. Okay, crystal clear. So note this down if you want to note it. Okay, but I advise you to definitely note it down, because this is so beneficial and important for learning algebra, okay, further. Okay, so this was it for this video, and okay, so this is the end. We have covered it.